Good afternoon, ladies and gentlemen. Welcome to the program on circular bioeconomy solutions for industrial decarbonisation, which will be presented by Dr. Chee, Chairman of the International Association for Agricultural Sustainability. This session highlights the factory-in-factory waste-to-energy technology, an innovative pyrolysis and gasification solution that transforms industrial biowaste into renewable energy, biochar and bio-oil. By preventing methane release from landfills or open burning, FIF directly mitigates greenhouse gas emissions and supports industrial decarbonization. Mr. Lee, please.
Okay, good afternoon, everybody. Thanks for coming. Before I go into the detail what this technology is doing, I would like to give a brief introductions on the IAS. That is the Association for the Agricultural Sustainability. So what we do is, this association, IAS, is a non-profit organization founded about 10 years ago. Our whole mission is actually try to accelerate the transfer of the technologies to the private industry to achieve so-called sustainable and resilient food production system. And of course, we need to look into the convergence of technologies and climate actions and of course, the natural capitals that is presented to the industry. Now, the focus area, of course, climate positive innovation is very important. And of course, we focusing on the regional collaborations. The reason for that is Singapore is a small country. So we don't have a lot of space for the technologies to be exploited. So we are looking into regional collaborations. And of course, most importantly is translating the R&D to impact from our understandings, the way we scout for the talent and technologies out there. We do know we have enough technology. We have enough talent, but somehow it's not able to match to the industry that needed them the most. So basically, our core value proposition is turn ambitious climate and sustainability goals into scalable, very important, and also bankable and implementable projects. So here on this side is to show how we execute the missions and visions of IAS. So we have three major clusters. The first cluster is actually on the talent. We need to have talent. We need to have technologies. And we find we can actually look for a lot of these wonderful, beautiful people who got the knowledge to share. Now, the key is the industry. So we had to match them to the needs. So the problem statement coming from industry is very critical. And we should be able to identify what is the actual tree that these scientists is able to help them to buck. Now, once we align them, identify, we need to bring the private sector to benefit from the transfer. Because the scientists can't really go and do commercial. We need private sectors to come in to work with the scientists and to execute the technologies. And they become the recipients of the technologies. And hopefully, there will be job creation for their country and also the wealth created for the nations. Now, when we do all this, we are actually there are some challenging in the funding because all the translation requires some form of funding to get started before VC will pay attention to it. So we do have our investor cluster coming together and help us to translate the IP or know-how into a bankable project. So now, back into the problem statement that we are talking about today, that is the waste. In agriculture, and we know 1/3 of the biomass from the agriculture is actually food. The other 2/3 is actually a waste. So as a result, the more food we produce, more waste we are going to have. And the best way or easiest way for the farmer to get rid of the waste is to burn it off, because it's very challenging for them to convert them to some useful material due to their limited capability. So we know the complications and the effects of burning and not to dispose the waste properly. Now, we do encounter some farms is actually try to bury the waste under the ground, but that's not that good because the soil becomes acidic. It will affect the drinking water. So now what we're trying to do is how can we find a way, a bankable, scalable solutions to mitigate these emissions and also to expand the so-called renewable energy to support the industry that needed the energy. So what we have here is actually factory-in-factory concept. And just to tell you, this technology is very interesting. If you look at it, the name is not unique. You can see that a lot of this technology using these two names. But what is unique about this technology is actually translate from the pharmaceutical industry, where they extract the nutrient from the plants, okay, for the pharmaceutical purpose. So that extraction method, and we incorporated into the system here, which the products coming out is completely reusable, and there's no emission of any gas into the environment. So the key most important thing is we extract the oil and the liquid out from the plant, for example, or any biological waste. And that is a very high value byproduct because they are nutrients. So we are inviting scientists from all over the world to look at this nutrient, what can they use for? And of course, the gas will be coming out to generate energy, and then all the carbon will be captured as a biochar. So we don't release the CO2 or methane into the air. So this is a very good concept, and it's modular. That it depends on the amount of the waste the factory or the company has, that we can actually expand according to the needs. So the value we have, not just on the energy given to the companies that is producing the waste, we also have a lot of high value products like biochar and the bio oil coming from the process. So this is how it looks like. The system 1 is PMET, pyrolysis extraction system. System 2 is actually gas generations. Using this example, if we process 300 kg per hour of the palm oil kernel cake, the reason I'm using this as a model is because in Southeast Asia, we do have an oil palm, right? So oil palm waste are plentiful, and they have a lot of this produced from the mill. And using this as an example, and the output from the PMET, pyrolysis extraction system, will be the gas, yeah? And the gas is actually fit into the other side for the power. But we do have the biochar. As I say, there is a carbon sequester, high value biochar, and also liquids and oil. Now the output from this guy is basically gas generation is produced the energy. Yeah. So what's most important part is the energy we put in here is 20 kilowatts and 10 kilowatt hour here, and the total output is 200 kilowatt hours. So which means it's very efficient system that you take out more energy than what you actually have to put in to process the bio waste. So it's very self-sufficient in energy use. In other words, the usage of energy in when the system is rather low. Now, this is just to compare the technologies with what we know in the market. So traditional incineration, which we know is just to burn it off. Yeah, of course, when you burn it off, it will give you the energy. And then versus the other one is actually anaerobic digestion. So the difference between these two versus our system here is the feedstock. Here, it doesn't matter what feedstock, it all can be used. But for this, because it's burning, it requires dry solid waste to be more effective. If it's wet, liquidy, it cannot be used. Now, contrarily for this guy, will be focused more on high moisture, biodegradable material, because there is a fermentation. So if you're using certain material that cannot be degraded, the bacteria cannot function. So there are limitations in both of the traditional methods. Now the process principle, here's basically high temperature, just to burn it off. And here is the microbial breakdowns of the biomass. Now for us, it's a thermolysis, molecular gasification, and extraction. It's a very unique pharmaceutical technologies that is coming to the environmental space waste valorization system. Now the energy, of course, we have syngas, biochar, bio oil, and also these are the good thing. But here basically heat and steam, and this type will be the biogas, which also many methane. Now byproducts reuse complete. Okay, there's no wastage. We not even release the CO2 into the air because the C will be captured as a biochar carbon. That's what we want. And of course, for the traditional methods, it's very low, moderate for the anaerobic digestions. Pollutions, none. Basically, you don't smell anything compared to anaerobic, which is very smelly, right? Because there's fermentations. Here, of course, high flue gas from the traditional incinerations. Now, energy efficient, as I showed you just now, put in 30 kilowatt hour, you get 200 kilowatt hour coming out compared to the other two. And carbon impact is truly a carbon sink, so it's biochar. So right now in the industry, there are processes to produce biochar. There is carbon capture. But the requirement of the feedstock is very, very rigid. It has to be so dry, so hard, that not efficient for the other two methods, but it's good to produce biochar. But for us, we don't have that issue. And of course, the system feature is modular. So which means depends on the need, you can expand based on the modular system and on-site. This one, obviously, you talk about a lot of things you have to put in to control the pollutions. And of course, this is matured, but the feedstock is limited. All right, so the economic value, obviously, this particular system is very efficient compared to the other two traditional methods. So for this COP30, what we do here is actually align with the COP's objective. So I'm not going into detail. This is obvious. And what I want to show you is the three major products. So energy, understood, is very green, is safe, it's good. And these two are the key. In fact, when we look at it, this one at the moment gives the highest return because biochar is very variable. It ranges from $2 per kg to $100. Depends on the quality of productions. And with our system, the biochar is high quality. You can fetch about $40 per kg. And the bio oil or bio liquid, this one is untapped because these are nutrients coming from the plants. So we are inviting scientists to use those products because it depends on the feedstock. If it's banana pulp, for example, or the pineapple waste, for example, so they have certain nutrients from those plants. And those extracts of the nutrient can be used for unique application. For example, stem cells culture, which the culture media is very expensive, produce single cells protein and whatnot. Some even go to the extent of the cosmeceutical and pharmaceutical products. So the value for the bio oil, bio liquids is very, very high. Now this one just to use case to show you in Malaysia, as for example, because of the oil palm industry. So based on a typical mill, this is considered small in Malaysia standard. They actually process 30 tons of fresh fruit punch per hour. That's considered a very small mill. Now, based on that, we calculated it needs 5 units of the FIF. Okay, 5 FIF units to process this amount of the waste. Now, this is a table, look at the annual value. So, with the 5 units of FIF, it can produce this is the palm kernel cakes, 12,000 tons a year, and the energy generated is 7 gigawatts. That is a lot, all right? And also, of course, you look at all the other products, like the biochar is 1,800 tons, and the oil is 600 tons. Now, if we convert this to dollar, we have total revenue of 1.7 billion USD per year coming from this. And all these numbers here are very conservative numbers. Now, if you look at the cost for the capex, initial capex is 3.6 million USD for the 5 units, and then the OPEX per year is $420,000. So if you look at it, now our net revenues, and more importantly for investors, they look at the payback, right? The ROI. So the ROI is 2.7 years. So it's very attractive that this technology with such a low capex, such a high return, and you can able to process all the waste at a very efficient way. Now, of course, all this one can be adjusted, depends on the quality of the product that is coming out from the process. Okay, now, is it only for the palm oil? No. So we can look at the livestock waste, okay? Now, for livestock waste, what we think is, in fact, this one you don't have to burn it and convert it to energy because this could be the protein we need for the aquaculture. Right, it's higher value because of protein. So we just have to dry it up, we'll do. No need to burn because we want the protein. But for the plants, you can have post-harvest and also processing waste, yeah, coming from both angles. Any crops will do. Doesn't really matter because it's very efficient. Now, I'll give you one example in Singapore. Singapore, we try to plant trees. So at this moment, we estimated we have 7 million trees in Singapore. And we trim the trees every day because we make sure that the branches won't fall down and hurt anybody. So the waste coming from trimming is about 185,000 tons per year. That's a lot of waste. So if I process this, I can able to generate 120 million kilowatt hour per year of power. And what does that mean? So in Singapore, we have the so-called the housing flat. So based on a 4-room housing flat, we can actually able to support 26,000 of a household per year. Just coming from the waste we need to trim from the tree. So there are a lot of such biological waste in every country that can be processed using the FIF method. Okay, so now as a country, we will look into much more than just offering technology. We also look into how can bring the green finance to support the adopter, right? So if anybody who wants technology, there's always some limitation on finance. This is something we can do. And of course, the carbon creditable biochar, that's high value, high grade biochar will give you very good carbon credits. And of course, the adoption and application of this. So this is the job of the IaaS. That is, once we identify good technologies, we will help to replicate to all over the world. Yeah, because a non-profit, so we're always looking for the host or the company that can benefit from this technology to address the challenges that they have in their respective country. So in summary, this is very compelling technologies. We have looked at it, tested and operated, and key is replicable, easily replicated, right? For all kinds of the bio-waste and be able to address all the necessary so-called climate and environmental challenges. And of course, this is what we try to do to support your targets of decarbonization. So the other side is just a flow of the FIF. All right, so with that, so these are the contacts. We welcome you to contact us if you're interested with this technology and to see how can this help you address the bio waste that you are facing today, and we can help you to how to address it. And because we are agile, flexible, we are non-profit, we identify good technology and we wanted it to share to the world. And that's why we are here. So this is just one of the use cases we have under IaaS. We are the gold sponsor for COP in Singapore Pavilion. We have another project will be showcasing in 19 November. Okay, that will be on the conservation of the mangrove forest. Because to conserve mangrove forest, that is a cost. So who's going to bear the cost? So we must have a financial engines to finance the conservation. So once we identify this is the problem statement, we identify technologies that can address how can any technology can help us to conserve the mangrove so that this conservation exercise or the objective can be achieved. So that will be the next week presentation. So welcome all you to come to see us again. Thank you. Any questions? I'm more than happy to answer any questions that you might have.
Thank you for your presentation, and I really appreciate the technology. I'm just wondering so I'm from Vietnam, so we have a lot of factories that are planted among rice paddy. So I'm just wondering, in terms of coming from rice, does it have the same benefits as well as like the ROI, or like all the numbers that we see from palm oil? Like, does it fluctuate a lot in terms of, depends on the input, or is it kind of consistent across?
For the rice straw, in fact, it's easier to process because it doesn't have the oil. Yeah, because the PKC still have a lot of oil in there. So there's a process. It's how to get the oil out first before you can burn it off. So the straw is actually very good. And we do encounter, let's say in India, there are projects because they have a lot of rice. And they try to grow cow to eat the straw. Impossible. There's no way you can solve that problem, right? So with that kind of process, you can have your power grid at the remote area to process it. Because to us, the key is energy. Once you have energy, you build a community. Once you have a community, you build the industry. That's very powerful concept, right? Because it's energy, but energy must come from somewhere. So the waste is actually an asset, but unfortunately nobody able to use it properly. So rice is a wonderful thing because rice, the waste is collected. Yeah, you collect the rice and you harvest it, and then the straw is left behind. So basically, it's there on site. So the collection is not an issue for rice. So same thing for millet, for corn, the collection is not a big issue. So these are a very good bio waste that can be used to produce this.
So from the conceptual perspective, I think this is a very good technology. But what have you seen? Sorry, this is my last question. What have you seen is there challenges for factories or company to actually install or adopt this technology?
Yeah. So from our experience, is the some factory just don't have the finance to install it because, like it or not, it costs about $700,000 per unit. Even though the ROI is 2.7 years, they just don't have the finance capability to invest. So we actually working with the bank to finance it because as a loan. And then the bank always say, how are you going to pay back the loan? I say it's energy sales, right? We just have the agreement with the company that, okay, you buy the energy back. You're going to buy the energy from the grid anyway. You pay for this energy. And that enough for us to justify loan from the banks to finance the whole installations. Now, of course, later on, subsequently, the biochar and the bio oil, so this will be profit sharing. So that this company, first, their waste is carried off. They still have the energy because they are paying energy anyway. And we're using that payments to pay for the finance. But they have other dividends from the biochar and bio oil. Yeah. So what we try to make it do is because doesn't matter how good is the technology, the adoption is difficult because they don't have the money to adopt. So you make sure that part is addressed. So that's why we're actively working with the banks and see how can we support the industry in that manner.
Hi, thank you for your presentation. I'm Dana, I'm from Costa Rica. Our economy is based on tourism. Do you think this technology could be applied to the hotel sector and touristic sector?
What sector is that?
Hotels, for hotels. And using the waste that they produce from the food, the waste from food and other residues.
So if it's biological waste, yes. Yeah, because biological waste, because it's easier to process that one. So that's why we use biological waste because we can have charcoal, capture it. And in fact, the charcoal, the biochar is very powerful. You can use it for packaging material, which we are not favor for that because the transition of the carbon is very rapid. You capture and then release back as a packaging material, you dispose it off. We will prefer the biochar used for the construction, building material, right? Build the bricks, right? And the wall, and even furniture using the charcoal. Because you look at the extreme of the biochar or carbon is diamond. So if we can convert the carbon into diamond, it will hold it forever. So now is how can you create products that can hold this carbon for longer period of time. If anything that is used for disposable, the transition is very short. So we would like to have it convert to something longer so that, let's say, for building material, could be 20 years, could be 30 years. So if every house hold the carbon for 20, 30 years, beautiful, right? And of course, we always invite the scientists to look into how to use this material, and the IP belongs to them. And then we help them commercialize it because, again, IS is an association. We are here to make things happen, make the R&D impactful. We're not here to extract the value.
Thank you very much.
So my colleagues, Dr. Fu is here, Shani. So, after the session, you guys welcome to talk to us. We can send you more information if you want to know more about it. Yeah, and welcome to go to our website because this association is really not money-making association. It's just the one to make science impactful. So we reach all over the world looking for the talents, yeah, and then we bring them and make it happen. Co-invest in it, bring in investor, make it bankable, and then we not just scaling it, it's actually replicating it to each country. My girl says, since you asked questions, she wants to give you this book. This book is actually published to celebrate our 60th anniversary, our independence. So 1 year, 1 chapter. So there are 60 years of independence. So there are 60 stories in there. Thank you very much. Sorry. For you. Oh, one more we have. My boss is here. So you too. Thank you very much. Yeah. Okay, Kia.
Okay, thank you, Dr. Lee, for the insightful presentation and for sharing how the factory-in-factory waste-to-energy technology can drive industrial decarbonization. We hope today's session has given everyone a clearer understanding of how the technology can turn industrial bio-waste into valuable resources and contribute to decarbonization. Thank you all for your time and participation. We invite you to continue having the conversation with the team after this session. Have a wonderful afternoon ahead.